Your attention, please. Please do not smoke in the terminal building. Smoking is only permitted in the specified smoking areas. Thank you.
Ladies and gentlemen, welcome on board G03 James Airlines Flight G4 with service from Measures of Variation to Box and Whisker Cloth. I am Charity Montefolca, your cabin crew, and on behalf of our captains and crew, we would like to give you an entertainment with educational purpose about our destination. Let us start with Measures of Variation. Measures of variation are ways to describe the distribution or dispersion of your data. In other words, it shows how far apart data points are from each other. There are 6 measures of variation: the range, the quartile deviation, the interquartile range, the mean deviation, the variance, and the standard deviation. This is also used to determine how varied, dispersed, scattered, or distant, or how close, clustered, or near performances of the members of the group are. One of the measures of variation is the range. Range is one of the simplest measures of variation. It is the lowest point of data subtracted from the highest point of data, and it shows the 2 extreme scores of a set of data. Now we have here an example. All we need to do here is to find the range of this set of numbers: 12, 11, 15, 14, and 16. The first thing we'll do is to arrange these numbers from lowest number to highest to make it easier and organized. Next is we only need to subtract the highest number and the lowest number. So 16 minus 11 is equals to 5. So 5 is our range. For a group of data, the range can be calculated by subtracting the lower boundary of the lowest class interval from the upper boundary of the highest class interval. I have here an example. We need to find the range of this group data. So we have measurements of height by centimeter here of 40 people. 151 to 152, 153 to 154, 155 to 156, 157 to 158, and 159 to 160. Remember that to find the range in a group data, we need to subtract the upper class boundary of the topmost limit and lower class boundary of the bottom class limit. So here's the solution. Range equals to upper class minus lower boundary. In the upper class, we need to add 0.5 here, so 160.5, and we minus 0.5 here to the lowest boundary. Now we have 150.5. So 160.5 minus 150.5, and it is equals to 10. And 10 is our range. However, I only remember how to compute range. With that, I would like to encourage everyone to participate if they know about the other topics.
Hello everyone, I'd like to volunteer. By the way, my name is Desiree Mingito, and I am a licensed professional mathematics teacher. And I'd like to compliment our cabin crew, Miss Montefolca, on a job well done. Interquartile range and quartile deviation are the next topics I'll cover. So, what is the interquartile range, or IQR? The IQR measures the spread of the middle half of your data. It is the range for the middle 50% of your sample. Use the IQR to assess the variability where most of your values lie. Larger values indicate that the central portion of your data spread out further. Conversely, smaller values show that the middle values cluster more tightly. The interquartile range formula is the first quartile subtracted from the third quartile. For example, consider the following numbers. After we remove observations from the lower and the upper quartiles, we are left with 4, 5, 5, 6, and quartile 1 is 4, and quartile 3 is 6. Then follow the IQR formula, so the interquartile range would be 6 subtracted to 4 equals 2. Quartile division is based on the difference between the first quartile and the third quartile in the frequency distribution, and the difference is also known as the interquartile range. The difference divided by 2 is known as quartile division or semi-interquartile range. For example, consider a data set of the following numbers: 22, 12, 14, 7, 18, 16, 11, 15, and 12. You are required to calculate the quartile division. First, we need to arrange data in ascending order to find quartile 3 and quartile 1 and avoid any duplicates. Using the quartile division formula, we have 17 subtracted to 11.50 divided by 2. So 17 subtract to 11.50 is equal to 5.5 and divided 2, so the quartile division is 2.75.
Thank you, teacher, but I would like to interrupt. I remember the topic was about computing mean deviation, and yet I forgot about how to compute it. Is anyone would like to help and share its idea about this topic?
Miss, I think I know that. Allow me to discuss that topic quickly. Hello everyone, I am Raxor Padihitog and I am just a normal passenger who wants to enjoy life and travel. So when we talk about mean deviation, and to understand it quickly, it is the mean of the absolute values of the numerical differences between the numbers of a set, such as statistical data, and their mean. There are two ways to solve the mean deviation for the ungrouped data and grouped data. Ungrouped data, to solve ungrouped data, let's have this example. 6, 10, 14. Using the formula, mean deviation equals summation of the absolute value of x minus m sub n divided by n. X is the score in the distribution, m sub n is the mean, and n is the number of elements in the given distribution. First thing we must do is to make a columns like this and fill in the given score. To fill in the blank column, we need to find the mean first. To calculate the mean, we need to sum up all of these scores given it and divide it by the number of elements given in the distribution. 6 plus 10 plus 10 plus 14 is equals to 40, divided by 4 equals 10. Therefore, our mean is 10. To fill in the blank column, we need to subtract the mean into the score to determine its absolute value. For example, 6 minus 10 is equals to negative 4, which is the absolute value of 4. After we fill it all in, we will sum up the absolute value. Therefore, summation of x minus m sub n equals to 8. Mean deviation is equals to summation of the absolute value of x minus m sub n divided by n is equals to the mean deviation equals 8 divided by 4. Therefore, our mean deviation for ungrouped data is 2. For group data, the formula used is md is equals to summation of f of the absolute value of x minus m sub n divided by n. Let's have this given example. Class interval is given as well as the frequency with the total frequency of 50. Therefore, we need to look for the midpoint, which is the x, as well as f of x or fx. To determine the midpoint, we need to add the first number of the class interval to its second number, like 0 plus 10, and divide it by 2, so that the midpoint of 0 to 10 is 5, and so on. To find the f of x, we must multiply midpoint to frequency. After that, sum it up to have summation f of x, which is 1350. Next, we need to add the columns for absolute value of x sub m minus m sub n and f absolute value of x minus m sub n. To determine summation of x sub m minus m sub n, we need to compute first the mean. Summation f of x divided by total of frequency. So 1350 divided by 50 equals to 27. Since we have the mean, we need to subtract midpoint value to our mean, which is 27, to determine the summation of x sub m minus m sub n. After that, we need to multiply each frequency to each result of the summation of x sub m minus m sub n to determine our f absolute value of x minus m sub n, and then sum it all up to get our summation of f of the absolute value of x sub m minus m sub n divided by n. As a result, MD equals 472 divided by 50. Therefore, our mean deviation for group data is 9.44.
Hi, I am also a teacher and I would like to volunteer in discussing about variance and standard deviation. So variance is the average square deviation from the mean, while standard deviation is the square root of this number. Both measures reflect variability in a distribution, but their unit difference. Standard deviation is expressed in the same units as the original values. An example of variance and standard deviation variance of the following data set: 2, 7, 3, 12, 9. The first step is to calculate the mean. The sum is 33 and there are 5 data points. The mean is 33 divided by 5 equals 6.6. Then you take each value in data set, subtract the mean and square the difference. For instance, for the first value, 2 minus 6.6 times 2 equals 21.16. The square differences for all values are added. 21.16 plus 0.16 plus 12.96 plus 29.16 plus 5.76 equals 69.20. The sum is then divided by the number of data points. 69.20 divided by 5 equals 13.84. So the variance is 13.84. To get the standard deviation, you calculate the square root of the variance, which is 3.72. To calculate the variance, you first subtract the mean from each number and then square the result is to find the square differences. You then find the average of those square differences, and that's all the variance of standard deviations. Thank you. I hope it helps.
I would also like to volunteer. Thank you, Ma'am Kima. It really helped a lot. Let me share to you about z-scores. A z-score describes the position of a row scores in terms of its distance from the mean. When you measured in standard deviation units, the z-score is positive if the value lies above the mean, and negative if it lies below the mean. Z-score is also known as the standard score because it allows comparison of scores on different kinds of variables by standardizing the distribution. And this is the formula for calculating a z-score, where x is the row score, mu is the population mean, and sigma is the population standard deviation. As the formula shows, the z-score is simply the row score minus the population mean divided by the population standard deviation. For example, let's say you have a test score of 190, the test has a mean of 150 and a standard deviation of 25. Assuming a normal distribution, your z-scores will be here. The z-scores tell you how many standard deviations from the mean your score is. In this example, your score is 1.6 standard deviations above the mean. Z-scores is useful to standardize the various row scores of a normal distribution by converting them into z-score because it allows researchers to calculate the probability of a score occurring within a standard normal distribution, and enables us to compare two scores that are from different samples which may have different means and standard deviations. And that's all. Thank you.
Thank you, Madam, and thank you everyone for sharing helpful informations with us. Lastly, I would like to share with you about our last destination, which is the box and whisker plot. A box and whisker plot is a graphical representation of variation in a set of data. A histogram analysis is sufficient in most cases, but a box and whisker plot can provide more details while allowing multiple sets of data to be displayed in the same graph. Why we should use a box and whisker plot? Because they can summarize data from multiple sources and display the results in the single graph. It is very effective and easy to read. It enables data from different categories to be compared for easier and more effective decision making. When you have multiple sets of data from different sources, you can use box and whisker plots like test scores of students, data from before and after process change, data from duplicate machines that manufacturing the same products, and many more. Again, this is our last destination, the box and whisker plot. Thank you.
Ladies and gentlemen, we have just landed at CCSA International Airport. G03 James Air welcomes you to Box and Whisker Plot. On behalf of your flight crew headed by Rexer Paduhinog and the rest of the team, we thank you for choosing G03 James Airlines, your airline of choice. Thank you.